Okay. I think we're reading notes today. Talking about the brain. Oh, I was supposed to rename the stream. Lessons about the brain. So I think that updates on Twitch, but not on YouTube. All right. So as per usual, we're not going to read everything here. We're just going to go through, find my notes. So a huge idea here is your brain is not about thinking. In fact, the idea that our brains evolved for thinking has been the source of many profound misconceptions about human nature. Once you give up that cherished belief, you will have taken the first step towards understanding how your brain actually works and what its most important job is, and ultimately what kind of creature you really are. Common ancestors, yada, yada, yada. Every action you take or don't take is an economic choice. Your brain is guessing when to spend resources and when to save them. So this is yet another type of homeostasis type of perspective. The scientific name for body budgeting is allostasis. It means automatically predicting and preparing to meet the body's needs before they arise. So yeah, this is like homeostasis is kind of the perspective of your body regulating itself like in the moment as if it was reactionary. But allostasis captures that forward-looking aspect of this process, meeting the body's needs before they arise. The value of any movement is intimately bound up with body budgeting by allostasis. All right, so gray, I don't know why, I probably shouldn't do it this way, but gray is more important than yellow. That's how I've been going about it. But we can say that, what is your brain's most important job? It's not rationality, not emotion, not imagination or creativity or empathy. Your brain's most important job is to control your body, to manage allostasis by predicting energy needs before they arise, so you can make efficiently make worthwhile movements and survive. Your brain continually invests your energy in the hopes of earning a good return, such as food, shelter, affection, or physical protection, so you can perform nature's most vital task, passing your genes on to the next generation. So I want to maybe write down some of this stuff for the homeostasis section here. Just, yeah, here we go. Brain's most blah, 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 blah. Ba, 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 ba. Let's get that in here. Let's go. Oh no, it's missing most important job. Why is it missing all the U's and M's to make worthwhile? Any W while. I should just write this out. So you can. They arise. So you can efficiently. What is going on out there? Oh my gosh. Worthwhile movements. That's crazy. And the V as well. Movements and survive. Your brain continually, and then, yeah, the V invests your energy. I should have just typed this. This is insane. Return such so you can perform nature's most vital task, passing your genes to the Oh, an X. It's going to be one of those streams today, isn't it? All right, restream. I'm keeping an eye on you. But we might need to yank that if this is going to keep happening when more people are here. Of course, your brain does think and feel and imagine and create hundreds of other experiences, such as letting you read and understand this book, but all of these mental capacities are consequences of a central mission to keep you alive and well by managing your body budget. Everything your brain creates, from memories to hallucinations, from ecstasy to shame, is part of this mission. You and I do not experience our every thought, every feeling of happiness or anger or awe, every hug we give or receive, every kindness we extend, and every insult we bear as a deposit or withdrawal in our metabolic budgets, but under the hood. That is what is happening. This idea is key to understanding how your brain works. Yo! Got a little time before the First Lady and I watched Suits last episode. Thank God. Is it not good? Or is it just long? The idea is key to understanding how your brain works and, in turn, how to stay healthy and live a longer and more meaningful life. All right, so the first lesson, you have one brain, not three. This is like an assault against the idea that, you know, first there was the lizard brain, and then on top of that you got the mammalian brain that like adds emotion, and then on top of that you've got like the human brain that adds like rational thinking. That is actually antiquated now, to my own chagrin. No, I like it, but the show is so long. I see. Oh no, I have to change the name of the stream again. Lessons about the brain. Stanner in the manor. Well, I don't know if I would call this place a manor, but what is good, Onion Helmet? Welcome back to more brain talk. Yeah, so this was like the idea that scientists had, which is now antiquated. It's like we've got this instinctual survival brain on the bottom here, and then we got a limbic system, mammalian emotional brain that's in the middle, and then on top of that, you've got this rational brain. Because one of them is... Okay, so it's wrong. The triune brain idea is one of the most successful and widespread errors in all of science. It's certainly a compelling story, and at times it captures how we feel in daily life. For example, when your taste buds are tempted by a luscious slice of velvety chocolate cake, but you decline it because honestly, you just finished breakfast. It's easy to believe that your impulsive inner lizard and your emotional limbic system pushed you in a cake-word direction, and your rational neocortex wrestled the pair into submission. But human brains don't work that way. Bad behavior doesn't come from ancient and unbridled inner beasts. Good behavior is not the result of rationality. And rationality and emotion are not at war. They do not even live in separate parts of the brain. God damn. All right. I have to find the place that I need to be talking about this. I think it's right here, the evolved structure stuff. I should write this down. I already knew this. Good stuff. Yeah, honestly, I feel like people still talk like this, and yeah, I certainly did not get clued in on how wrong that perspective was until I did these deep dives into the brain, and then it's nice to just hear someone say it straight out. Live in separate parts of the brain. Okay. Intuitively, I mean, it encourages skepticism. Right, right. Okay, I see. It would be a good troll if you and I responded to everything Stan talks about with this. Done it a few times. You're based. Oh, it's just to say I already knew this. Yeah, that'd be pretty funny. I've got like the finished version of the entire document, and I hand it off, and you just look at it, and you're like, I knew this. What is it? Why did you work on this for the past 4 years of your life? Okay. So it talks about how we got there, how we ended up with this type of thinking. By the 1990s, experts had completely rejected the idea of a three-layered brain. It simply didn't hold up when they analyzed neurons with more sophisticated tools. So I am so far ahead of the curve that they figured this stuff out in the 1990s. But the problem is, like, you still have people purveying this type of perspective online today. You know, so that's I mean, it's not that big of an issue. I feel like the stakes are pretty low here, but when we get to more complicated topics, it's always good to have like a foundation, a bedrock that is more apt. It turns out that as brains become larger over evolutionary time, they reorganize. Let me explain with an example. Okay. You know what? I should read all of this stuff because it's actually really cool. In the early days, scientists compared one animal brain to another by injecting them with dye, slicing them paper thin like deli meat, and squinting at the stained slices through a microscope. Neuroscientists who study brain evolution today still do this, but they also use newer methods that allow them to peer inside neurons and examine the genes within. They've discovered that neurons from two species of animals can look very different but still contain the same genes, suggesting that those neurons have the same evolutionary origin. If we find the same genes in certain human and rat neurons, for example, then similar neurons with those genes were most likely present in our last common ancestor. Using these methods, scientists have learned that evolution does not add layers to brain anatomy like geological layers of sedimentary rock. But human brains are obviously different from rat brains, so how exactly did our brains come to differ if not by adding layers? Turns out that as brains become larger over evolutionary time, they reorganize. Let me explain that with an example. Your brain has 4 clusters of neurons or brain regions that allow you to sense your body's movement and help create your sense of touch. These brain regions are collectively part of the primary somatosensory cortex. In a rat brain, however, the primary somatosensory cortex is just a single region that performs the same tasks. If we simply inspected human and rat brains by eye, as they used to do, we might come to believe that rats lack 3 somatosensory regions found in the human brain. We might therefore conclude that these 3 regions are newly evolved in humans and must have new human-specific functions. Scientists have found, however, that your 4 regions and the rat's single region contain many of the same genes. This scientific tidbit suggests that something about evolution, namely the last common ancestors of humans and rodents, which lived about 66 million years ago, probably had a single somatosensory region that carried out some functions that our 4 regions do today. The single region most likely expanded and subdivided to redistribute its responsibilities as our ancestors evolved larger brains and bodies. This arrangement among brain regions, segregating and then integrating, creates a more complex brain that can control a larger and more complex body. Okay, it's tricky business to compare brains of different species to discover what is similar because the path of evolution is twisty and unpredictable. What you see is not always what you get. Parts that look different to the naked eye can be similar genetically, and parts that differ genetically can look very similar. And even if you do find the same genes in the brains of 2 different animals, those genes can have different functions. Thanks to recent research in molecular genetics, we now know that reptiles and non-human mammals have the same kinds of neurons that humans do, even those neurons that create the fabled human neocortex. This is huge. I don't know why I didn't highlight that. Okay, thanks to recent research in molecular genetics, we now know that reptiles and non-human mammals have the same kinds of neurons that humans do, even those neurons that create the fabled human neocortex. Human brains did not emerge from reptile brains by evolving extra parts for emotion and rationality. Instead, something more interesting happened. Yo, look at this guy. I didn't know lampreys were chilling like that. Scientists have recently discovered that the brains of all mammals are built from a single manufacturing plan, and most likely the brains of reptiles and other vertebrates follow the same plan. Many people, including many neuroscientists, are not familiar with this work, and those who know about it are only beginning to reckon with its implications. Crazy stuff. The common brain manufacturing plan begins shortly after conception with an embryo when an embryo starts producing neurons. The neurons that form a mammal's brain are created in an astonishingly predictable order. The ordering holds true for mice, rats, dogs, cats, horses, anteaters, humans, and every other mammalian species studied so far. And genetic evidence strongly suggests this order holds for reptiles, birds, and some fish. Yes, to the best of our knowledge, you have the same brain plan as a blood-sucking lamprey. Never be known as the one funny guy in the group. Uh-oh. Why not? Fortunately, I don't think that was ever my role, but how come? Stands the... Oh, Stands the one funny guy in our group, we just say, hey, funny guy, and it's him, and he says, yo. I'd be down with that. I'd be down with the irony of that. Just a piece of advice. Trust me on this. Nice. I'm gonna just walk into every room just going, yo, it's me, the funny guy. If the brains of so many vertebrates develop in the same order, why do these brains look so different from one another? Because the manufacturing process runs in stages, and the stages last for shorter or longer durations in different species. The biological building blocks are the same. What differs is the timing. So you can imagine that the time that is spent building what ends up to be the neocortex for humans is actually quite small in these other species. The biological building blocks are the same. What differs is the timing. For example, the stage that produces neurons for the cerebral cortex in humans runs for a shorter time in rodents and a much shorter time in lizards. So your cerebral cortex is large, a mouse's is smaller, and an iguana's is tiny. So they each have neurons with very similar DNA. But just because the development, like the developmental duration for these parts of the brain were differed in length, it leads to different structures. And you can imagine all kinds of different types of structures happening from different recipes, you could say. That means we're wicked smart. I think that does lead to us being intelligent in the way that we think about it. If you could magically reach into a lizard embryo and force that stage to run for as long as it does in humans, it would produce something like a human cerebral cortex, though it wouldn't function like a human one. Size isn't everything, even for a brain. Right? Like, I imagine this process obviously has to take on a very slow evolutionary path to ensure that the recipe is actually good for functioning. Why is the author writing like this? Like what? First about the cake, all descriptive, And now size isn't everything. Oh my gosh, they're coming at you. She's assaulting us cake loving, modest humans. So the human brain has no new parts. The neurons in your brain can be found in the brains of other mammals and likely other vertebrates. This discovery undermines the evolutionary foundations of the triune brain story. And then, okay, so it talks about how, like, whether or not our brain is actually large compared to the size of our body. And I think we get there. All mammals have a relatively big cortex and a brain that's relatively large for their body size. Our cortex is just a scaled up version of the relatively smaller cortex found in relatively smaller brain monkeys, chimps, and many carnivores. It's also a scaled down version of the larger cortex found in the larger brains of elephants and whales. If a monkey's brain could grow to human size, its cerebral cortex would be the same size as ours. Elephants have much more cerebral cortex than we do, but so would an elephant-sized human brain. The size of our cerebral cortex, therefore, is not evolutionarily novel and does not require any special explanation. The size also says nothing about how rational a species is. If it did, our most famous philosophers might be Horton, Babar, and Dumbo. Western scientists and intellectuals concocted the idea of the big rational cortex and have kept it alive for many years. So yeah, size isn't everything. The real story is that during the course of evolution, certain genes mutated to cause particular stages of brain development to run for longer or shorter times, producing a brain with proportionately bigger or smaller parts. So you don't have an inner lizard or an emotional beast brain. There is no such thing as a limbic system dedicated to emotions, and your misnamed neocortex is not a new part. Many other vertebrates grow the same neurons that, in some animals, organize into a cerebral cortex if key stages run for long enough. Anything you read or hear that proclaims the human neocortex, cerebral cortex, or prefrontal cortex to be the root of rationality, or says that the frontal lobe regulates so-called emotional brain areas to keep irrational behavior in check, is simply outdated or woefully incomplete. The triune brain idea and its epic battle between emotion, instinct, and rationality is a modern myth. Bum bum bum. Well, we know Dumbo. I think Dumbo, the elephant, right? I don't know. Oh, Horton Hears a Who? I'm guessing that's the other one. Horton Hears a Who. I don't know who Babar is, though. Okay. To be clear, I'm not saying that our big brain has no advantages. What advantages does it provide? The answers will unfold in the lessons that follow. And while it's true that we're the only animal that can build skyscrapers and invent French fries, these abilities are not due to our big brains alone, as we shall see. Moreover, other animals have evolved abilities that surpass ours in significant ways. We don't have wings to fly. We can't lift 50 times our own weight. We can't regrow amputated body parts. Such abilities are superhero powers to us, but business as usual for allegedly lesser creatures. Even bacteria are more talented than we are at certain tasks, like surviving in harsh, unfamiliar environments, such as outer space or the insides of your intestines. Okay, so this is the big idea that we've talked about before. I will not tolerate this slander. We are number one. When you give a Dorito to a squirrel, it'll spend the rest of its life looking for that taste again. Guess what, buddy? I can just go to the store. That line on bacteria, I have a big problem with. Is it the fact that we don't find ourselves inside of an intestine, or is it because they don't they can't survive in outer space? Like, is it not? Or are you hung up on the semantics of talented? Natural selection did not aim itself towards us. We're just an interesting sort of animal with particular adaptations that helped us survive and reproduce in particular environments. Other animals are not inferior to humans, they are uniquely and effectively adapted to their environments. Your brain is not more evolved than a rat or lizard brain, just differently evolved. Um, oh, it had extreme environments. Well, yeah, I think she's just pointing out that there are skills that we think would be superhuman, right? Like if I could go out into space and not have to wear an oxygen helmet. I think that's all she's saying. She's not trying to make any like the whole point of this thing is to not make any type of more skilled uh you know arguments. I think that's the whole point of the argument. It doesn't it doesn't or it's inappropriate to make an argument that any animal is like more talented than another animal that at something like in this evolutionary perspective. Now, granted, we could have these discussions of like you know whether bacteria is better or something like that, but this is the same argument as to whether like who won the evolutionary game, and no one wins the evolutionary game. You could say like you win if you survive, and we could point out that bacteria are in a much better position to survive than humans are. But yeah, it's like that. That's you could just start talking about that type of thing forever. All right, if that's the case, why is the myth of the triune brain still popular? Why do college textbooks still depict a limbic system in the human brain and say it's regulated by the cerebral cortex? Partly because those experts need a better public relations department, but mostly it's because the triune brain is a story that comes with its own cheering section. With our unique capacity for rational thought, the story goes, we triumphed over our animal nature and now rule the planet. To believe in the triune brain is to award ourselves a first prize trophy for best species. The idea of Plato's war with rationality versus emotion and instinct has long been Western culture's best explanation for our behavior. If you restrain your instincts and emotions appropriately, then your behavior is said to be rational and responsible. If you choose not to act rationally, then your behavior may be called immoral, and if you're unable to act rationally, you are considered mentally ill. But what is rational behavior anyway? Here we go. Now you know why I like this book so much. Oops. Oh my gosh. Traditionally, it's the absence of emotion. Thinking is viewed as rational, whereas emotion is supposedly irrational. But that isn't necessarily so. Sometimes emotion is rational, like when you feel afraid because you're in imminent danger. And sometimes thinking isn't rational, like when you scroll through social media for hours, telling yourself you're bound to come across something important. Perhaps rationality is better defined in terms of the brain's most important job: body budgeting, managing all the water, salt, glucose, and other bodily resources we use every day. In this view, rationality means spending or saving resources to succeed in your immediate environment. Let's say you're in a physically dangerous situation and your brain prepares you to flee. It directs your adrenal glands, which sit atop your kidneys, to pump you full of cortisol, a hormone that provides a quick burst of energy. From a triune brain perspective, the cortisol rush is instinctual, not rational. But from a body budgeting perspective, the cortisol rush is rational because your brain is making a sound investment in your survival and the existence of your potential offspring. This isn't to say that we should commit to some use of the word rational here. The point is really just assaulting our colloquial use of rational in how we usually think about it. Like in the document, I try to make like the concept of rationality as something felt. So I don't try to make the case like I don't tell a story that like our brain just acts rationally because it's doing body budgeting. That's just what it does. And you can from your perspective, you could think that what it's doing is rational or not. I think like the closest to home way we can think about rationality is the feeling of rationality. That something, it feels rational to you. When I say that this is a pen, that feels rational to me. That might feel rational to you if you understand what a pen is, or recognize a pen. but yeah, by grounding like the concept of rationality in the feeling, we can see how different people might think different things are rational, and then we need a different heuristic for what is actually a dispute settling gauge, or how should we deal with two people that think two things are rational. It's not my fault. I was sexily created to be fit to live on Earth and not be a blob. Had enough with these bacterialists. We effed. I have to fire Restream, and I think I have to just get Restreamer, which I think I run locally, because this is getting out of hand. That's the second time it happened today, but I think I could just do this myself, because currently my stream is going to Restream and then it outputs it, but I think I could do both at the same time. Do this. Can you hear me? Yeah, no, it's because Restream is not a reliable tool. So oh, and it's changed the name again to New Year, New Stream. That's a bummer. This makes it harder for me to create the transcripts, because now I have different streams that I have to do separately and throw them all together. It's no fun. All right, well, let's continue. Okay. Right, so she's actually being careful enough by saying, from a triune brain perspective, the cortisol rush is instinctual, not rational. So she's actually playing a good linguistic game here by not committing to some ambiguous assertion. Restream definitely acts like it's been bought by private equity. Yeah, I mean, it's been doing this for the past 6 months or so. Yeah, maybe ever since I started using it. I just don't think it's a reliable enough tool. I think we're gonna have to switch it out. Unfortunate. Maybe that'll be I don't know when I'm gonna want to spend that time. So maybe this week. Depends how long it's down for. Okay, if you return home from war to a safer environment, but your brain continues to false alarm, as happens in post-traumatic stress disorder, that behavior could still be considered rational. Your brain is protecting you from threats it believes are present, even though the frequent withdrawals decimate your body budget. The problem is your brain's beliefs. They are not a good fit for your new environment, and your brain hasn't adjusted yet. What we call mental illness, then, may be rational body budgeting for the short term that's out of sync with the immediate environment, the needs of other people, or your own best interests down the road. Rational behavior, therefore, means making a good body budget investment in a given situation. When you exercise vigorously, you may have a rush of cortisol in your bloodstream and you may feel unpleasant, but we'd consider exercise rational because it's beneficial for your future health. The surge of cortisol when you receive criticism from a coworker might also be rational because it makes your glucose available so you can learn something new. These ideas, if taken seriously, could shake the foundations of all sorts of sacred institutions in our society. In the law, for example, attorneys plead that our clients' emotions overwhelmed their reason in the heat of passion, and therefore they aren't fully to blame for their actions. But feeling distressed is not evidence of being irrational or that your so-called emotional brain has hijacked your supposed rational brain. Distress can be evidence that your whole brain is expending resources towards an anticipated payoff. Many other social institutions are steeped in the idea of a mind at war with itself. In economics, models for investor behavior assume a sharp distinction between the rational and the emotional. In politics, we have leaders with clear conflicts of interest, such as past lobbying work in industries that they now oversee, who believe they can easily set aside their emotions and make rational decisions for the good of the people. Beneath these lofty ideas lurks the myth of the triune brain. So this is why we have to believe that certain people are just corrupted or unconsciously biased, as we came up to. You have one brain, not three. To move past Plato's ancient battle, we might need to fundamentally rethink what it means to be rational, what it means to be responsible for our actions, and perhaps even what it means to be human. Okay, we can chill on this for a second and go to my Gemini conversation that followed. Yo, Lisa, I'm gonna need you to pipe down a little bit. Who's Lisa? Or is this something that you're saying in the context of what I just read? That's also false. Not all economics believe in Homo economicus. Yeah, I think it's just pointing out maybe that a lot of our models are like have that perspective baked in. All right, so I say I have read the first 2.5 lessons from 7.5 lessons about the brain. Okay, you know what? We just did one, right? So let's do it. Let's do number two. Let's do number two here. All right. Today we remain surrounded by so-called facts about the brain that are just metaphors. If you've heard that that the left side of your brain is logical and the right side is creative, that's just a metaphor. So is the idea that your brain has a system 1 for quick, instinctive responses and a system 2 for slower, more thoughtful processes, concepts discussed in the book Thinking Fast and Slow. He's very clear that system 1 and 2 are metaphors about the mind, but they are often mistaken for brain structures. Some scientists describe the human mind as a collection of mental organs for fear, empathy, jealousy, and other psychological tools that evolved for survival, but the brain itself isn't structured like that. Your brain also does not light up with activity, as if some parts are on and other parts are off. It does not store memories like computer files to be retrieved and opened later. These ideas are metaphors that emerge from beliefs about the brain that are now outdated. Aren't I reading the book on the right? I am reading the book on the right. Yep. And we are on lesson 2. And I think we're only going to do lesson 2, and then we can jump over to that other conversation, and then we can continue with the other lessons maybe tomorrow or whatnot. I'm not done finishing the book, so we'll see. We'll see. The answer to these questions begins with an important insight. What were the questions? What kind of brain do we have? What kind of brain gives our ability to cooperate, our capacity for language, and our talent to guess what other people are thinking or feeling? Okay. Your brain is a network, a collection of parts that are connected to function as a single unit. A brain network is not a metaphor. It is a description that comes from the best available science about how brains evolved, how they're structured, and how they function. Okay. Yep. So we got neurons, explaining neurons connected. This arrangement of neurons knits your 128 billion individual neurons into a network. To make things simpler, I'll refer to this whole arrangement as the wiring of your brain. So here we go. This is a neuron. We got the axon. We got dendrites. With the signals going downward here. Comes in through dendrites. We were talking about dendritic logic previously, where like logic is actually happening before it even reaches the cell body. We got the synapse connecting the two neurons connected by synapses. This is where electrical signal becomes straight up chemicals. Chemicals pass through, then gets translated back into electrical signals. In the cell body, there's basically like a buildup of electrical signals, and if and only if that hits a certain threshold, will there be a action potential, which is what has this thing shooting the signal to the next point in the system, or it'll actually affect any of the neurons that it's connected to. But once again, this is like a very messy analog system where energy is just kind of like lost somewhere else. Like one of these dudes can just like float off to the side or get eaten up by something, or there's a ton of stuff going on here. There's a lot of inhibition signals, so that it's not just exciting signals. There's like, imagine a bunch of like inhibition signals and exciting signals are coming together and they're getting canceled out in like literal chemistry. All right. Your brain network is always on. Your neurons never just sit around waiting for something in the outside world to make them fire. Instead, all your neurons chat constantly with one another through their wiring. Their communications may become stronger or weaker depending on what's happening in the world and in your body, but the conversation never stops until you die. Communication in your brain is a balancing act between speed and cost. Each neuron directly passes information to just a few thousand. So this one dude is talking to a few thousand other neurons and receives information from a few thousand others, give or take, yielding over 500 trillion neuron-to-neuron connections. That's a really big number, but it would be considerably larger if every neuron spoke directly to every other neuron in the network. Such a structure would require so many more connections that your brain would run out of resources to sustain itself. So, like, imagine every single neuron is connected to every other neuron. That would be very costly. Yo, Darmadon, what's good? Oh, I see. You said Lisa, and I didn't even put two and two together. I'm gonna need you to pipe down a bit. Yeah, written by Lisa. How long did it take for you to read this? Like this chapter? I've been doing like one chapter a night, kind of. Sometimes a little more, sometimes a little less. Hey gang, how are we? We're doing well. Darmadon, what's good? Stress, just got scammed. Dealing with that, but trying to think of something else. Oh man, I'm sorry to hear. Yeah, it's rough. That's a good point. We should do a day on scamming at some point, given that we're all about AI and whatnot here. We should talk about what kind of things, like what is the front lines of scamming right now. But let's get off that topic because you don't want to think about it. All right. So you have a more frugal wiring arrangement that is sort of like the global air travel system. Yep, here comes another metaphor. So this is actually really cool and really helpful. The air travel system is a network of about 17,000 airports around the world. Whereas your brain carries electrical and chemical signals, this network carries passengers, and if we're lucky, our luggage. She's got jokes. Each airport runs direct flights to some other airports, but not to every other airport. If every airport sent flights to every other, air traffic would increase by billions more flights per year, and the whole system would run out of fuel and pilots and runways and ultimately collapse. Instead, some airports take the burden off the rest by serving as hubs. There's no direct flight from Lincoln, Nebraska to Rome, Italy. So you first fly from Lincoln to a hub like Newark International Airport in New Jersey, then hop onto a second, longer distance flight from the hub to Rome. You might even take 3 flights and pass through 2 hubs on your journey. The hub system is flexible and scalable, and it forms the backbone of international travel. It allows all airports to participate globally, even while many of them focus on local flights. Your brain network is organized in much the same way. Its neurons are grouped into clusters that are like airports. Most of the connections in and out of a cluster are local. So, like an airport, the cluster. So when we talk about like a brain region, we can imagine this type of complexity, like a cluster, or clusters that are just talking to themselves, and then we got hubs that are actually talking long range. Most of the connections in and out of the cluster are local, so like an airport, the cluster serves mostly local traffic. In addition, some clusters serve as hubs for communication. They are densely connected to many other clusters, and some of their axons reach far across the brain and act as long-distance connections. So, going back to this guy, the axons can be quite long. Like a single neuron's axon can be, can go pretty far. Brain hubs, like airport hubs, make a complicated system efficient. They allow most neurons to participate globally, even as they focus more locally. Hubs form the backbone of communication throughout the brain. So this is like a cool image that I wish that we could steal, but I don't want to put an image into the document. So like in each of these hubs, it's a cluster of a bunch of neurons, but then these hubs might be able to, like, you know, reach across the entire brain in terms of their communication. Hubs are supercritical infrastructure. When a major airport hub like Newark or London's Heathrow, I don't know, goes down, flight delays and cancellations ripple across the world. So imagine what happens when a brain hub goes down. Hub damage, so this is what we were talking about with the consciousness video, like lesion studies when there's brain damage to certain parts of the brain. Hub damage is associated with depression, schizophrenia, dyslexia, chronic pain, dementia, Parkinson's disease, and other disorders. Hubs are points of vulnerability because they are points of efficiency. They make it possible to run a human brain in a human body without depleting a body budget. So when these neuroscientists are considering what parts of the brain are most closely connected to consciousness, they're seeing which hubs are getting rid of the entire conscious experience once they go down. Cheers, guys. Does anyone use any reading tracking sites or apps? Something like that would be cool for the Twitch philosophy community. Reading tracking sites or apps. I do use Goodreads. I'm not logged in here, but I also, if I were to connect Goodreads to this channel, I would have to make a new Goodreads. But yeah, that would be pretty sweet. I don't know what that gains us, but I bet it does give us stuff. Like maybe we could have a community section. Read era, nice. I just use it in isolation though. Yep, same. I just like having a log where I can just see all the things. Same with Letterbox. It's just cool to be able to sort through your stuff. But it's also cool to get a friend and then you can sort through their stuff and see what they like the most and use that for recommendations. I can imagine there's something similar. Oh, I can imagine there's something better. Yeah, I guess it would. What kind of features would we want out of that? Okay. You can thank natural selection for this lean and potent hub structure. Scientists speculate that over evolutionary time, neurons organized into this kind of network because it's powerful and fast, yet energy efficient and still small enough to fit inside your skull. Your brain network is not static. It changes continuously. Sound familiar? Some changes are extremely fast. Your brain wiring is bathed in chemicals that complete the local connections between neurons. These chemicals, such as glutamate, serotonin, and dopamine, are called neurotransmitters, and they make it easier or harder for signals to pass across synapses. So when they're talking about these chemicals right now, even though they are neurotransmitters, they're acting as neuromodulators, which the difference is, going back to here, whereas a neurotransmitter is like actually getting past, you know, as we see here, from one neuron to another via the synapse. Neuromodulators are released more diffusely, such that, like, you can imagine that they're coming from some other area and then they're getting involved in this situation, so that they prime or inhibit synapses such that that signal is more easily passed or less easily passed. And I think maybe they affect the cell body. I'm not sure. I think they affect the action potentials. I need to go more in depth into neuromodulation at some point. Probably not that important, given that I have a semi-functional understanding of it. Okay. Oh, they talk about this. Okay. They're like an airport stat, blah blah blah. These networks change. These network changes happen instantaneously and continually, even as your physical brain structure seems unchanged. In addition, some of these chemicals, such as serotonin and dopamine, can also act on other neurotransmitters to dial up or dial down their effects. When brain chemicals act in this way, we call them neuromodulators. All right. They're like the weather between airports. When it's clear, planes fly quickly. When it's stormy, flights are grounded or rerouted. This is a crazy metaphor for that, but neuromodulators and neurotransmitters together allow your brain's single structure to take on trillions of different patterns of activity. Other network changes are relatively slower. Just as airports build or renovate their terminals, your brain is constantly under construction. Neurons die, and in some parts of the human brain, neurons are born. Connections become more or less numerous, and they become stronger when neurons fire together and weaker when they don't. These changes are examples of what scientists call plasticity, and they occur throughout your life. Anytime you learn something, a new friend's name or an interesting fact from the news, the experience becomes encoded in your wiring so you can remember it, and over time, these encodings can change that wiring. So even stuff that that are unconscious, that we're not aware of because they're just not like that salient that it reaches conscious awareness, are still involved in this process and become encoded in some sense, even though we don't understand that they are. Your network is also dynamic in another way. As neurons change conversation partners, a single neuron can take on different roles. For example, your ability to see is so intimately tied to an area of the brain called the occipital cortex that the area is routinely called the visual cortex. However, its neurons routinely carry information about hearing and touch. In fact, if you blindfold people with typical vision for a few days and teach them to read Braille, neurons in their visual cortex become more devoted to the sense of touch. Remove the blindfold and the effect disappears after 24 hours. Similarly, when babies are born with dense cataracts, meaning the brain receives no visual input, neurons in the visual cortex become repurposed for other senses. Some neurons in your brain are so flexibly connected that their main job is to have many jobs. An example is one part of your famous prefrontal cortex called the dorsomedial prefrontal cortex. This brain region is always engaged in body budgeting, but it's also regularly involved in memory, emotion, perception, decision-making, pain, moral judgments, imagination, language, empathy, and more. Pretty cool. Overall, no neuron has a single psychological function, though a neuron may be more likely to contribute to some functions than others. Even when scientists name a brain area after a function like visual cortex or the language network, the name tends to reflect the scientist's focus at the time rather than any exclusive job performed by that part of the brain. I'm not saying that every neuron can do everything, but any neuron can do more than one thing, just like a single airport can launch planes, sell tickets, and serve crappy food. That depends if there's a Chick-fil-A there. It's also the case that different groups of neurons can produce the same result. Try this now. Reach for something in front of you, like your phone or a chocolate bar. Draw your hand back and reach for it again in exactly the same way. Even a simple reaching action like this, when done more than once, can be guided by different sets of neurons. This phenomenon is called degeneracy. Scientists suspect that all biological systems have degeneracy. In genetics, for example, the same eye color can be produced by different combinations of genes. Your sense of smell works by degeneracy too, and so does your immune system. Transportation systems have degeneracy as well. You can fly from London to Rome on different airlines, on different flights, on different models of airplane, in different seats, with different flight attendants. Co-pilots can take over for pilots. Degeneracy in the brain means that your actions and experiences can be created in multiple ways. Each time you feel afraid, for example, your brain may construct that feeling with various sets of neurons. Filthy degenerate neurons. Very nice. Yeah, I was trying to figure out why this word, why degeneracy? Like, because when we think about degeneracy, we're like, I don't know, what comes to my mind is something that's like almost an antonym of generate. So it's like something getting taken away, and something that's degenerate would be something that's like, I don't know, less than generate. Um, but in this sense, degeneracy is referring to like a more complicated type of thing where it's like the like a chair could be made up of different kinds of wood and stuff like that. But the interesting thing here, I always try to point it out that this is also occurring for our thoughts. So when I say that, our understanding of a pen is different from moment to moment, even though the experience feels the same, it's also referring to the fact that the very neurons that are being activated in the moment that we're looking at the pen or thinking about the pen are slightly different from moment to moment, creating a similar, and I always say pragmatically similar experience, such that, it feels like it's the same, such that you recognize it's the same thing over time, etc. Even if it's different neurons. But let's pipe down Lisa. What's her problem? She's spitting. She's spitting facts. We've now seen how helpful it is to understand the brain as a network. This perspective captures so much of the brain's dynamic behavior: slow changes by plasticity, faster changes by neurotransmitters and neuromodulators, and the flexibility of neurons with multiple jobs. A network organization has another advantage as well. It furnishes a brain with a special characteristic that is key to creating a human mind. This characteristic is called complexity. It is a brain's ability to configure itself into an enormous number of distinct neural patterns. So, just to give a reminder, when we were doing the whole consciousness discussion, there's a lot of neuroscientists who are specifically interested in complexity as something that is, giving us a sense of whether or not a species is conscious or how conscious they are. That led to that PCI, let's do it over here. PCI, perturb complexity index. Right, to assess the level of consciousness based on the complexity of the brain. So this was the thing where it's like if you perturb the brain in a certain spot, and if you find, you perturb the brain close to one of these hubs, then, obviously you're going to see, more of an output than if you were to perturb the brain in some, periphery. But, you perturb the brain in certain ways and you see the output. Like, what is the, how does that signal propagate throughout the brain? How complex is that propagation? Okay, in general, a system with complexity is made of many interacting parts that collaborate and coordinate to create a multitude of patterns of activity. Complexity empowers a brain to act flexibly in all kinds of situations. It opens doors so we can think abstractly, have a rich language, spoken language, imagine a future very different from the present, have the creativity and innovation to construct airplanes and suspension bridges and robot vacuum cleaners. Complexity allows us to contemplate the whole world beyond our immediate surroundings, even outer space, and care about the past and the future to the extent that other animals do not. Complexity alone does not give us these capabilities. Many other animals have complex brains too. Complexity is a critical ingredient for these capabilities, and the human brain has it in abundance. In the brain's case, what constitutes complexity? Picture billions of neurons, each one sending signals to other specific neurons all at once, using neurotransmitters, neuromodulators, and other dynamic bells and whistles. That whole picture is one pattern of brain activity. Complexity means that your brain can create massive numbers of different patterns by combining bits and pieces of old patterns it has made before. This result is a brain that runs its body efficiently in a world full of constantly changing situations by recalling patterns that helped it in the past and generating new ones to try. So it's because of our complexity that we can think about abstractions. Like that's a good example of like a clear use case here. I was looking in the mirror and I was a super old woman with a huge floppy neck. Then I was like, wait, I don't look like that. Then I looked in the mirror again and it was me as like a 40-year-old. Interesting. Yeah, this goes. This connects to the idea that our brain is creating these, controlled hallucinations. It's telling us what to see rather than like rather than the actual physical thing actually telling us what to see. So she gets into. I just threw the pen. She gets into predictive processing soon. That's like one of the later lessons coming up, that our brain is predictive, and that's the type of thing she talks about. She points out how your brain is like, what's most important is your brain is giving top-down signals that's telling it what is actually in front of you, and then it's only taking information from the outside world as signals of error, as signals of what you think is happening is not actually what's happening, and that gets us, that actually changes it up. So it flips our entire way of thinking about how we experience the empirical world. We think that, phones in front of us, photons hit our eyes, we put that through a filter, then that's what reaches our consciousness. But it's rather that our brain is predicting what we're looking at before the photons even get to our brain, and if there's a mismatch, and that mismatch is deemed important enough, that's another part of the brain that, it's determining whether it even matters. When you were looking at the mirror and you saw the old woman, for a short bit of time, your brain was not in a mode of, all right, we need to really correct this right now. But obviously over time it did that. So you as a 40-year-old, as in you looked like an old woman, or you as a 40-year-old as in you shapeshifted? It was like a 90-year-old woman that then changed to a 40-year-old me. Whoa, I'm 28, by the way. Nice. I believe in the breezeful afterlife out of sheer spite that there isn't a fountain of youth in this world. Whoa. We got to enjoy it while we have it, Okay, a system has higher or lower complexity depending on how much information it can manage by reconfiguring itself. So yeah, the fact that we have all these systems in place, plasticity, neuromodulation, etc., allows us to create all sorts of complexity that a static brain would not be able to deal with. And that's given the fact that there's as many connections as it mentioned, some trillion, many trillion. All right, this was an interesting thing. We can explore higher or lower complexity by considering two imaginary brains that are less complex than yours. The first imaginary brain has about 128 billion neurons, like yours does, but every neuron is connected to every other. When one neuron receives a signal to change its firing rate, all the other neurons eventually change in kind because they are all connected. We'll call this one meatloaf brain because its structure is so uniform. Functionally speaking, meatloaf brain has lower complexity than yours because at any point in time, its 128 billion elements are effectively just a single element. So it's really important that we have different brainwave frequencies happening at the same time. Like that is contributing to the vast complexity that we get over meatloaf brain. But also, a second imaginary brain also has 128 billion neurons, but it's carved into puzzle pieces that serve dedicated functions: seeing, hearing, smelling, tasting, touching, thinking, feeling, so on, like the brain imagined by phrenologists in the 19th century. This brain is like a collection of specialized tools that work together, so we'll call it pocket knife brain. Pocket knife brain has higher complexity than meatloaf brain, but much lower complexity than your brain, because each tool adds little to the total number of patterns that pocket knife brain can make. A real pocket knife with, say, 14 tools can open into about 16,000 possible patterns, 2 to the 14th to be precise, and adding a 15th tool merely doubles the total. Your brain's neurons, however, have multiple functions that increase the number of patterns exponentially. If you had a 14-tool pocket knife and added one additional function to each tool, say making the blade serve as a crude bottle opener, using the screwdriver to punch holes, and so on, The total number of patterns leaps from 16,000, 2 to the 14th, to over 4 million, 3 to the 14th. In other words, when existing brain parts become more flexible, the result is much more complexity than we get by accumulating new parts. I hope Jeff Bezos hurries up and funnels his multi-billions into anti-aging research. Then someone can pull an Edward Snowden. How are those connected? Or are you talking then someone can pull a Benjamin Button? That's what we're looking for, right? Or are you saying that someone in Amazon tells everyone what's going on? Meatloaf brain and pocket knife brain may have some advantages, but a brain with high complexity beats them both. Brains of higher complexity can remember more. A brain doesn't store memories like files in a computer. It reconstructs them on demand with electricity and swirling chemicals. We call this process remembering, but it's really assembling. A complex brain can assemble many more memories than either Meatloaf brain or pocket knife brain could. And each time you have the same memory, your brain may have assembled it with a different collection of neurons. That's degeneracy. So that's what I was just saying. Brains of higher complexity are also more creative. A complex brain can combine past experiences into new ways to deal with things that it has never encountered before. For example, you can climb an unfamiliar hill or staircase without tripping because you've climbed similar ones in the past. Complex brains may adjust faster to changing environments that require different body budgeting. It's one reason that humans can live successfully in so many climates and social structures. If you have to move from the equator to northern Europe, or from a laid-back culture to one with strict rules, you'll adapt more swiftly with a complex brain in your head. On top of that, higher complexity may make a brain more resilient to injury. If one collection of neurons stops working, other collections may serve in its place. That's one reason complex brains may be favored by natural selection. Pocket knife brain would not have this capability. Lost neurons would be more likely to mean lost functionality. Human brains may be some of the most complex brains on Earth, but they aren't the only ones with high complexity. Intelligent behavior has emerged many times in different species with different structured brains. Take the octopus, for example, whose complex brain is distributed throughout its body. Octopuses can solve puzzles and even dismantle their tanks in aquariums. Bird brains can be complex too. Some bird species can use simple tools and have a bit of language ability, even though their neurons are not organized into a cerebral cortex. The highly complex human brain isn't a pinnacle of evolution, remember. It's just well adapted to the environments we inhabit. High complexity may be a prerequisite for so much that makes you human, but by itself it does not empower a human brain to make a human mind. Your Paleolithic ancestors needed more than a highly complex brain to pick up a hunk of rock and imagine a future hand axe within it. Likewise, you need more than high complexity to look at a piece of paper, a piece of metal, and a piece of plastic, which are all physically different, and treat them all as having a similar function, like serving as money. High complexity helps you climb an unfamiliar staircase, but you need more than high complexity to understand what it means for someone to climb a social ladder to gain power and influence. We also need more than high complexity to contemplate the nature of a human brain and invent the many creative metaphors for what a brain is like, such as the triune brain, systems 1 and 2, and mental organs. These feats of imagination require a high level of complexity packaged in a really big brain, as well as other factors that you'll learn about in the coming lessons. As mentioned before, a brain network is not a metaphor. It's the best scientific description of a brain today. It allows us to consider how one physical structure reconfigures in an instant to integrate vast amounts of information efficiently. It reveals similarities and differences between various kinds of brains by quantifying their complexity. It even helps us understand how a brain might compensate when it's damaged. Okay. Metaphors are wonderful explaining complex topics in simple, familiar terms. A metaphor's simplicity, however, becomes its greatest failing if people treat the metaphor as an explanation. Genetics are sometimes described as blueprints, but that doesn't always tell the full story. The complex network in your head may not be a metaphor, but my description here is necessarily incomplete. Your brain is more than just neurons. It includes blood vessels and various fluids that I haven't talked about. It also includes other kinds of brain cells called glial cells. There we go. What was that one called? What's the one that eats things up that we joked about? I forget. That function in ways that scientists don't fully understand yet. Your brain network may extend surprisingly into your gut and intestines, where scientists have found microbes that communicate with your brain via neurotransmitters. But why is everyone so chill about what just went down in the Caribbean? Are we talking about the heist? The trying to find a tactical way of saying this. The exfil, the microglia. Yeah, that's what it was. The microglia, glial cell, which is running around eating up synapses that have been deemed tasty, or I don't know. It's like the chocolate cake that we were talking about. I think everyone's not chill about it, but what power does anyone have, right? That's the unfortunate thing. If I think you're talking about what I think you're talking about. I think there has been a lot of what's it called? Protests. There have been protests. I don't know if there have been protests across the country. I know there have been protests in New York, at least. I'd imagine it's across the country. Yeah, I don't think people are microglia. That's okay. All right. As scientists learn more about the brain and its interconnections, we may discover better ways to describe its function and structure. Until then, understanding the brain as a complex network allows us to ponder how a human brain creates a human mind without any need for an allegedly rational or oversized neocortex. If human brain evolution has a crowning achievement, it is the complexity of its crown. Very nice, Lisa. All right. The reason why this is... Oh, wait. I woke up and saw Mr. M in tracksuit, all dripped out with the sunglasses and whatever they put on him. I was like, all right, what the... Yeah. Yeah. No, I woke up and similarly was just like, what is going on? And probably not good. Probably not good. All right, the reason why the stuff that we read today is crazy is because it makes the consciousness discussion much more difficult. Previously, and I even spoke like this, I was saying that you can look at other species and see what parts of the brain they have, and if they don't have certain parts that we know make us conscious in certain ways, then we could say that they're not conscious in that way. But this whole discussion that we just had, especially lesson number 1, points out that might not be the case. And it's really about complexity. So this is why I think Damasio comes away with saying that like an ant might be conscious in some way, because it has that sort of complexity that allows it to... I think Damasio knows a lot about the ant's brain, and it's not about what it allows the species to do, even though that's like intuitive, but it's really what type of coordination can happen in an ant's brain, and that would tell us whether or not an ant might be conscious. And it seems like ants have pretty complex signal mappings that would not disqualify it from the consciousness discussion, which is insane. Now, once again, obviously, when we think about consciousness, Our understanding of consciousness is so biased towards what we experience that it's very difficult for us to intuit what an ant might be feeling if it is conscious. An ant's consciousness would not be similar to a human's. It would be very difficult to intuit what, or to empathize with an ant. But what we're seeing is that it's going to have some non-zero level of consciousness, whatever that means. But yeah, this makes it much easier to look at like a another mammal, such as like a chicken, and be like, okay, that animal probably experiences a highly sophisticated array of affect or emotions. Yeah. Crazy stuff. All right, if DiMaggio pulls something soon, Stan is going to detour with ant knowledge for the next few weeks. Oh, pulls off something. Yeah, what's DiMaggio's what's DiMaggio's next book? When is DiMaggio releasing his next book? Yeah, we're stopping everything for a DiMaggio book. If a lion could talk, we would not be able to understand him. Exactly. And who says that lions don't talk, you know? Oh my gosh. It's coming up. Next book is titled Natural Intelligence and the Logic of Consciousness. Oh my gosh. All right, we've got 7 months. 9 months, I'm sorry. We have 9 months and then we're getting Stunlocked by DiMaggio. This will follow his most recent major work, Feeling and Knowing, Making Minds Conscious. Oh, actually I have to read that. I have to get up to date with what he's saying since the book I read, which was published in 2021. Would you like me to help you find a pre-order link? Can I pre-order? Is this a real book? Oh, I can't just look that up. DiMaggio? Yes? 29. I'll buy that. Amazon? Oh, let me make sure I'm not doxing myself. Oh, no, bro. This is some Hollow Knight. Yeah, that's what it is. This is the release. Yeah, we should do a all-nighter for DiMaggio, for a DiMaggio book. How funny. I should ask DiMaggio if we could read it on stream for our, handful of people here. All right, we're only, okay, no, wait, 47 minutes in, but we also had a couple drops, so we're probably a little over an hour in. Okay, we could start going through this, especially since it's on topic. All right, so I have read the first 2.5 lessons from 7.5 lessons about the brain. I want to make sure that I understand the lessons about the brain, the one brain versus three brain, the triune brain thing. The triune brain model is antiquated and straight up wrong. As the book explains, we actually share the same, if not extremely similar, DNA with our distant ancestors and thus many other species, especially related to the brain. For each of these species, brain development happens in the same order, yet the size of different parts of the brain differs. The key difference of DNA comes down to how large the animal and, as a correlation, the brain is, and most directly, how long each of the parts of development last. This leads us to shared neurons with the same DNA, yet the architecture of the brain can significantly differ based on these different developmental recipes. All right. You have grasped the core argument of these lessons well. Here's the breakdown of your summary with some refinements to help you lock in the specific vocabulary and metaphors Lisa Feldman Barrett uses. All right, so the point, the triune brain model is antiquated and straight up wrong. Right, the old view was that evolution worked like a geological sediment, adding new complex layers over old primitive ones. Barrett explains that brains don't get upgrades by bolting on new parts. You don't have a lizard brain inside of a mammalian brain. You have one distinct integrated brain. The lizard parts are not separate, they are woven into the whole. Okay, the manufacturing plan. This is a crucial insight. Barrett refers to this as the common manufacturing plan. Almost all vertebrates, from hagfish to humans, go through the same stages of brain development in the embryo. Evolution modifies the duration of these stages. If a specific stage lasts longer in humans than in mice, that part of the brain grows larger and develops more neurons. This is why a rodent brain and a human brain can look radically different but act according to the same genetic rules. Think of it like baking cookies versus baking a cake using the same ingredients. If you change the time you spend mixing or the temperature of the oven, you get completely different structures, even though the fundamental components are identical. All right. I say this leads us to shared neurons with the same DNA, yet the architecture of the brain can significantly differ, and then says, yes, but let's sharpen the terminology. You identified that the architecture differs. The scientific term for the similarity you noted is homology. So homologous circuits. We don't just share DNA, we share specific types of neurons and circuits. A neuron found in a human prefrontal cortex might have a genetic sibling in a rat's brain, even if the rat doesn't have a clearly defined prefrontal cortex in the same way we do. The topography, the layout looks different because the dough expanded differently during development, but the raisins, neurons, are still in roughly the same relative positions to one another. Interesting. There's another cake metaphor. Yep. It's on Barrett's wavelength there. You have successfully dismantled the idea that your brain is a battlefield between rational thought and animal instinct. Okay, so then I say, okay, from here I want to determine if my inferences are apt because of these discoveries. This makes it much more difficult to determine what type or level of consciousness each species has. While we originally could consider that animals without a limbic system didn't experience emotions, and that all animals with a limbic system do experience emotions, we cannot do so anymore. We're not allowed to. From here, we can look to lesions to help us make sense of what each part of a species' brain does and consider how that relates to the product of human brain lesions. We have established that certain animals, like the rat, give us an apt idea as to how the human brain operates, yet there are significant differences, especially seen with drug trials. In the cases where it's something, a drug seems to work on a rat, but it doesn't work on a human. So lesions only give us a speculative view of animal consciousness. So we can't just say, if it has this lesion, then it loses this part of consciousness. Or, if it behaves in a certain way because it loses this thing, and it's a similar way to that, to how humans behave when we lose that. Like, we can't follow that anymore because we're not dealing with like the same structures that are just getting added on. We can consider how much complexity a species has, as Barrett, as well as the IIT crew. This is the integrated information theory. This is these are consciousness people that are specifically looking at complexity, and they're in the they're in the consciousness rundown here. Where would they be? This is it's got to be a materialist, right? Oh geez, I have to find it throughout this. Representational, relational, computational information. Nope. Oh no. Where would this actually be? Was I able to see this? Is an original radical model that proposes a definition for conscious experience and specifies which physical systems can possess it, starting from the phenomenology of consciousness. So this is where IIT, I pointed out, goes wrong, I think. So like you start with a phenomenological axiom, which I point out is contingent on our culture, our understandings. It translates these axioms into physical postulates based on intrinsic cause-effect power. featuring a mathematical measure to quantify a system's capacity for informational integration, which correlates with the degree of consciousness. So, I mean, I think it would be very useful to like follow some of the methodology here, but the axioms need to change. Okay, so this didn't really tell us where it is on this list. Okay, I'm not going to find this. Let's just move on. All right. So yeah, we can consider how much complexity a species has, yet this is also speculative as we don't have comprehensive measures of this aspect of complexity contributes to conscious experience in this particular way, right? The PCI, which I just talked about, the perturbial, what was it? Perturbial computation index? PCI? Consciousness? Complexity index. Oh my gosh. Perturbial complexity index gives us a sense of, you know, how much complexity is going on here, but it doesn't actually tell us, you know, anything about like the type of consciousness that's being had. You know, that index correlates with conscious states, as we talked about. Like you could see the difference between someone that's asleep versus awake versus in certain other states. You could see the meditative state versus the, you know, whatever state. And there's a lot of research on that, which is why, you know, there's a lot of eyes on that. But yeah, it would still be difficult to like use that on another animal. I mean, I guess that's a little bit better, right? You use that on another animal and you kind of see what's going on, but that still wouldn't necessarily give you a clear idea of exactly what type of consciousness is happening. This leads thinkers like Damasio to believe that even insects have some significant level of consciousness. Damasio seems well situated with the demolition of the triune model, as his levels of consciousness operate outside that framework, simply looking at what type of information is mapped. Okay, is this basically where we are regarding consciousness in other species? All right. You're connecting the dots between neuroanatomy, evolutionary biology, and the philosophy of mind that many miss. The central inference is correct. The death of the triune brain model removed the hardware checklist for consciousness. We can no longer look at an animal and say missing part X, therefore missing experience Y. Okay, here breakdown of the inferences refined against Barrett's framework in the broader field of neuroscience. The end of the limbic localization. While we originally could consider that animals without a limbic system didn't experience emotions, we cannot do so anymore. Correct and crucial. In fact, Barrett and many modern neuroscientists argue that the limbic system as a distinct functional unit doesn't even exist in humans. The old view, emotion lives in the amygdala limbic system. If an animal lacks this, it is an emotionless robot. The current view, affect, feeling pleasant, unpleasant, calm, agitated, is a whole body property derived from regulating the body. So, basically how we've been talking. Since almost all brains regulate a body, allostasis, almost all brains likely generate some form of affect. If a fish has a body budget to manage, it likely feels the strain of a deficit, unpleasantness. But yeah, what is that feeling like? That's the issue. All right, the limits of lesions and homology. Right, the problem of function versus experience. We can lesion a rat's brain and see it stop freezing in response to fear. We can infer the structure was necessary for the behavior. However, we cannot prove the rat felt fear, the subjective experience, or if it just broke the mechanical circuit for freezing. The drug trial failure. As you noted, this is why many psychiatric drugs work on mice but fail in humans. The homologous neurons are there, the ingredients are the same, but the microwiring, the cake structure, is different enough that the outcome, consciousness behavior, doesn't translate perfectly. All right, complexity and IIT. consider how much complexity a species has, yet this is also speculative. Yes, this is the current frontier. The IIT crew, Tononi et al., argues that consciousness is about integration, how much information the system weaves together. The triune models suggested a step ladder. The complexity view suggests a gradient. A fly is a non-zero level of integration. A dog has more. A human has a lot. As you noted, we have no phi meter to stick into a bee's brain. It remains a theoretical categorization, not an empirical tool. I think you can pin down a bee and you could use the PCI on the bee. So I don't know if this is absolutely correct, but I didn't push back on this one. Damasio seems well situated looking at what type of information is mapped. Okay, strong connection. Damasio and Lisa Feldman Barrett actually converge here despite some disagreements on emotions. We got to figure out what those are. Damasio believes consciousness begins with the proto-self, as I explained in the first video, the neural mapping of the body's internal state. If an insect maps its internal state to regulate survival, it has a flicker of consciousness, whatever that means, right? This aligns perfectly with lessons 1 and 2. If the brain's core job is allostasis, then the core of consciousness is likely the feeling of that budget. Conclusion, you don't need a massive cortex to feel hunger or pain. You just need a system that maps the body. This opens the door to insect consciousness, exactly as you surmised. All right, affect versus emotion. There is one distinct separation Barrett makes that is vital for your understanding of the rest of the book. Affect, the foundation, simple feelings of pleasant, unpleasant, or arousal and arousal, calm. Barrett argues many species have this because it comes from body budgeting. However, emotion, the construction, complex categories like sadness, awe, or, I don't know how to say this, schadenfreude. Barrett argues these are constructed by the brain using concepts learned from culture. Your current status, you have correctly realized that we can't deny animals' consciousness based on anatomy. However, Barrett would argue that while a rat likely has affect, it might not have emotions. It doesn't have the concepts of sadness to make sense of that bad feeling. This is like the mappings of mappings that Damasio talked about. So I say, I understand the difference between affect and the experience of concepts, which is actually quite a broad subject, as we often conflate the reflective linguistic thought about concept with the largely unconscious acted out aspects of a concept we later think about. For human consciousness, a key question I would have is, when looking at the higher levels of consciousness that Damasio discusses, how much of this is simply cortical mappings versus how much leverages the body to create complex linguistic conceptual thoughts, reconstructive abstract pattern recognition? For example, using minute motor movements to allow us to actualize linguistic expressions. I understand that much of our experience of meaning concepts is affect. The question really is how much of each and for which aspects of our intuitive experience. All right, the distinction you make between acted out concepts like the implicit and procedural and reflective concepts, linguistic and declarative, is vital. In fact, Barrett argues that the reflective part is really just a high-speed, low-energy version of the acted out part. Right, so yeah, like the acted out, the automatic is always at bedrock here. It's always the foundation that's even allowing anything else to happen. Including our thinking of linguistic, our thinking of words right now in our brains, like that is afforded to us by what's allowing us to, unconsciously act out our understanding. All right, here is the breakdown of how much is cortical mappings versus body leverage and how they mix to create meaning. Stan thinks thoughts are in his brain. Haha. So that this is what led me to go in this direction, I think, because we had that discussion the other day with Dr. K, and what Dr. K said almost stunlocked me. I'm not going to spend a whole video on it, but I was really thinking about that, and I wanted to represent that in this discussion. Trippy what he said. I don't know why he said it. It's not. It can make this more complicated for. I don't know if that's the right way to say it. It can be deceptive. Like it carries implications. People might infer things based on what he said. That I don't think is useful to infer. Because takes away a lot of practicality, I think. Now, granted, I think you could probably follow both the way he was talking about it and the way I'm trying to push here, and still, take the practical takeaways. But all right, the mechanism simulation. So this is a huge topic that came up in embodied cognition. The as-if loop, using minute motor movements to allow us to actualize linguistic expressions. So I was wondering, like, how, like, does our brain actually leverage our muscles at all in terms of, like, when I think about a word, is the brain leveraging any of my muscles in subtle ways? And it seems like the answer is not quite, but it's still like there's still parts of the brain that would perceive my actual mouth movements when I do that, and that's actually either feeling or predicting. We could always go the predictive route, predicting like those movements and creating that feeling for me in subtle ways that allows me to actually have these thoughts. And obviously these thoughts are built up from many different parts of the brain that are adding. We can imagine, especially following the global neuronal workspace theory, adding different aspects of that experience. Okay, keep that thought to yourself, Dr. K. He was making a larger point, though, something like meditation. You need to come at it from another perspective, not the physical. So I am liking the idea of, and hopefully this doesn't pre-bias me before we do meditation month too much, but I think it's very possible to come at meditation with a physical aspect, perspective, but it needs to be like apt. It needs to be right in like or it needs to be secure. It needs to be robust. Need phenomenology, ontology lens. Like, I think by knowing certain fundamental takeaways about the brain can really benefit your practice. But this is just speculation, and that's not to say that like someone's practice cannot be effective without it. I'm just saying, like, perhaps it could be more effective if what your thought, like similar to how like your top down thinking can affect like your immune system, how quickly you recover, how it can affect all these things that you would think should be like completely separate from our thoughts about what's happening. Like, similarly, I'd imagine that if your top-down thoughts was in alignment with what's actually happening under the hood, perhaps that could affect your trajectory in a way that's beneficial. All helps. Yeah, I'm sure if you're a physio, you'd be better at yoga. Yeah, I mean, yeah, yoga definitely is one of those areas where if you understand certain aspects, but like I don't know if we know some of the like some of the things that would be really beneficial if you see the parallel. Like, one of the most important things for me with yoga is understanding. We have to do yoga day too. I have to show something to everyone that my yoga instructor showed me, and it's really changed my life. But just like the understanding of how, first of all, how your core goes down through your legs, and how, like, when you're finding that bedrock in any pose, and also when you're like lifting furniture or doing anything really, even in your posture, like you can be mindful of your core, going all the way. This is like that feeling of your rooting your feet into the ground and feeling that, feeling pushing down onto the ground, by having the understanding of like the, I don't know, the scope of the muscles behind the scenes in that situation, can really give you I don't know, at least like a mindful heuristic when you're trying to do poses in certain ways. Like, it allows you to keep that bedrock. Hit the solar plexus chakra. I don't even know where the solar plexus is. I'm that out of the solar plexus. Chakra. Oh, is this not? Is this like a? The nerve plexus in the abdomen that is situated behind the stomach and in front of the aorta. Contains several ganglia distributing nerve fibers to the viscera. Huh. Like near your belly button, there's meant to be a chakra there. Okay, I need to understand what chakras are during March as well, because I probably don't have the requisite understanding. Okay, simulation. Barrett and the embodied cognition field call this simulation. You asked if higher consciousness is simply cortical mappings or if it leverages the body. The answer is the cortical mappings are leverages of the body. Thinking is motor planning. When you think of the concept apple, your brain doesn't just access a dictionary definition. It activates the neurons in your visual cortex, your auditory cortex, and crucially your motor cortex to see to see round/red, to hear the crunch, to mimic the hand shape of holding it and the mouth movements of eating it. The minute movements. You are correct. Even when you are sitting still and just thinking, your brain is sending low-level signals to your muscles. It is running the motor plan, but inhibiting the final execution. If you read the word kick, the part of your motor cortex that controls your leg fires. Crazy. It is effectively 100% embodied. There's no pure abstract thought floating in the cortex, detached from the body. All meaning is rooted in your body's sensory and motor systems. But one of the things that I've been learning is like how important inhibition is in terms of the network of the brain. Like there's regions in the brain that are solely responsible for inhibiting other regions of the brain, and the only way to like orchestrate behavior is to inhibit the inhibitors. You inhibit the first one, and it stops inhibiting the second one, and then the second one's able to start firing in the ways that it wants. So, and you know, it's not like it's like what I just said is overly simplistic. It's not like a region of the brain wants to do anything, but that's just like a way that you can interpret what's going on. All right, the equation of meaning. How much of your experience of meaning is affect versus concept? It is not a pie chart. It is more like a lens and a light source. Affect is the value, the why. Affect is the internal status report of your body budget. Allostasis, it tells you valence, good/bad, and arousal, calm/excited. It highlights what matters. Without affect, nothing has meaning because nothing has biological consequence. You would be an intelligent computer that processes data but doesn't care about it. So, and then concept is the shape, the what. Concepts are the predictions your brain constructs to explain why you feel that affect. It gives the affect a specific form. I feel bad. I am anxious about this exam, etc. But like, what I'm trying to imagine is like there's simulation happening at the parts of the brain that are deeply involved with our actual linguistic motor movements, and these are allowing us to have thoughts that follow that same language in our brain. So that's why language is so important for us to be able to comprehend complex concepts. It's because we literally simulate the motor movements of the language as we think about things explicitly. Like that's the type of story I think is going on here that I need to look deeper into. And that makes thoughts completely in the brain. You know, like that's where you find exactly what thoughts are in the brain. Okay. Stand hitting the yoga nidrasana and Sirsa Padasana. Upward facing 2-foot staff pose, maybe. I never looked into them much, but randomly after like 1,000 hours of meditation, I could feel cluster of sensations in the middle of my forehead that I never lost connection to. Nice. They are not a big part of my practice or study, so I rarely care to mention or defend them. But I do feel that sensation in my head a lot that day. A lot of the day. Got to see it. Yeah, I was actually noticing like when I was maybe it was a couple days ago when I was uh, doing the meditation that like my brain was feeling really weird. Like I think it's noticeable now because it's a very different type of processing that's happening. But I don't know how much of this is also just like affected by the fact that I am thinking about meditation in a certain way. So perhaps that's making signals that are causing that feeling. But I just don't know. Got to see a knee to ear pose. A knee to ear pose. How do those work? Think about it. I think I so I don't know what the I don't think I was able to do anything really impressive, like a crow pose. I think I just had gotten down the bridge, and that was kind of cool for me. I'm a big fan of half pigeon or pigeon. I don't know what the difference is, but uh, that stuff really burns. That stuff feels good. Provided we're not doing yin, because yin pigeon pose is rough. But it's also great. It's probably great to like straight up meditate through. I started yoga like a year ago and still can't touch my toes. Hey, it's like it's a slow progression, but you get there. Like it's crazy. You just you keep doing it, and you keep getting more flexible. That was the thing that was blowing my mind. It's like I was getting so much more flexible than I started out with, and I am not a flexible guy. So it's definitely a thing that you can do. Okay. All right, the synthesis. Meaning occurs when a concept successfully predicts and categorizes an affective state. So this is like straight out of the our document, right? This is exactly what I say. You feel a vague sense of doom. Okay, without concept, you feel a vague sense of doom, pure affect, but don't know why. Low meaning. Without affect, you know a fact, the sun is hot, but it feels irrelevant to you. Cold data, no felt feeling or meaning. So affect and whatever concept is here, though. But concept is a lot more than just, you know, this abstract idea of a concept in your brain. It's a bunch of different parts of your brain firing. You know, associative parts, linguistic parts. The what do we say in that last video? It's like linguistic self-report. I don't know what it's called, but all right. Damasio's extended cognition and language. Damasio's higher levels of consciousness, which he describes as, you know, if the first one was proto-consciousness, extended consciousness is, I think, maybe it's like proto-consciousness, then I don't know, complete consciousness or something like that, and then extended consciousness. This is where language enters as a teleportation tool. I don't know why it's using the word teleport, but the constraint. An animal without complex language can generally only regulate its body budget for the here and now. A dog creates concepts for this room, this smell, this owner. The linguistic hack. Words are efficient, compressed concepts. That's like a weird way of saying it, but it's like words allow you to keep track of a bunch of different states, and you can then make sense of those states using words as well. And now you get this like really complex system where we could actually understand things that are complex. All right, the word Paris is a sound wave that lets me trigger a massive simulation in your brain without us having to actually be in Paris. So, you know, when I hear this Paris, this word Paris, a lot of simulation is happening in my brain that is affecting, you know, things I see, things that I smell, things that I taste, etc. It's affecting things that I would say about it. This allows humans to manage their body budgets for the distant future, worrying about retirement, or the distant past, regretting an email. To answer your specific question, higher consciousness leverages the body more, not less. To understand the abstract concept of justice, your brain likely simulates a feeling of balance or a feeling of disgust towards unfairness. We use our physical body states to metaphorically understand abstract ideas. So, I mean, this is going towards that other stuff that we were talking about, you know, simulation in all kinds of different embodied ways. But what I'm trying to get at is, you know, what was being talked about up here, where, you know, at base level, even when you hear the word justice, like, you know, you've got all these things simulated. This is just pointing out that when we use terms that like metaphors, like like that person is above that other person in their math scores, right? Like we're leveraging parts of the brain that deal with physical space as well. And yeah. All right, all right. What do I say after this? I want to push slightly on a couple things here. Following the literature on embodied cognition, there certainly are limits with the extent to which it definitively shows simulation correlations for everything that we want to know about our conscious experience of concepts. Furthermore, even with simulation, I'm wondering how much of the conscious experience of concepts require minute muscular movements, for example, unnoticeable movements of the mouth/tongue, or if the conscious experience is simply a manifestation of neural signaling, which doesn't reach muscles due to inhibition. So I'm really trying to specify, like, hey, like, is our muscles being used at all, or is this simply just the neural signaling? This is okay. You have correctly identified the fault line between strong embodied cognition and weak embodied cognition. So strong demands peripheral body feedback, and weak posits central simulation. You will likely find the weak or neural simulation view more robust. Here is the nuance regarding the limits of simulation and the necessary muscle movements, and the necessity of muscle movement. The as if, the solution to the muscle problem. Most modern neuroscientists, including Barrett and Damasio, rely on the as if body loop to explain this. You see so the body loop. Brain, body acts. This is slow. The body loop. Brain, body acts, body gives feedback, brain feels it. You see a bear, your heart pounds, and you feel fear. That's slow. The as-if loop, so this is the predictive aspect here. The brain goes straight to the somatosensory cortex, direct shortcut. You see a bear, and your brain tells your sensory cortex to hallucinate the feeling of a pounding heart without waiting for the heart to actually pound. So this is how these top-down signals are literally affecting how we feel about the world before those feelings even come. And in a predictive processing perspective, the top down is the prior. The feeling that we would eventually get, like the actual physical feeling or the signals that come from those physical feelings, are actually just signals of error. It tells us whether or not our predictions are correct or not correct. But the predictions are actually taking authority before the bottom up signals are. Okay. Is this accurate? You think reality is becoming is beyond concepts, but the brain can't function without concepts? I don't know if I've ever said the reality is beyond concept. Oh, I see what you're saying. You think the reality is beyond. Okay, we can't put reality into concepts, but the brain can't function without concepts. And when we say the brain can't function without concepts, I think we mean that the brain can't make sense of the world without, concepts. And I think that's the case. So when we say that we can't capture reality, it's pretty much, it's not saying that there is a reality there that we're not capturing. It's like, it's more so that we couldn't possibly capture all the possible things we could describe about this reality. I don't know. It's like a theoretical space, it's not a space that is actually like absolute and ontological, as if there is some hidden truth that we're not grasping. It's just that we could not possibly grasp our experience with our concepts because, our concepts are like, when we think about our concepts explicitly, that's only a subset of all the things that are affecting how we feel consciously. Like, that's a better way to say it. Like, what we're leveraging, the simulation that we're leveraging when we're thinking about concepts is a subset of all that is being simulated and felt in our bodies, in our consciousness at one moment. So it's impossible. It's like different parts of the brain. So you wouldn't even be able to do that in words. And so, if so, is there anything in experience that is non-conceptual in your view? Anything is in experience, like affect is like, we attempt to categorize affect into emotions, but we find that there are so many different types of emotion, and we're trying to find patterns that we can, we can abstractly say that this is that emotion, but there's nuances to these emotions, and there might even be subcategories of that, and just because we're putting like some interpretive lens over it, we're putting it into a box and saying this is the emotion, that doesn't mean we actually understand the emotion. Like, what would it mean for us to understand the emotion? Like, this is kind of what I get at in the Consciousness 2 video. It's like we're merely trying to create another mapping on top of the mapping of what is felt here by putting this into, by representing what is felt into words. And our putting it into words is highly reductive. It's losing a lot of what was there. But like, that's, it couldn't capture everything. Like, that's not how words work. The only way to completely capture an experience is to experience it. Okay, but is it accurate you think concepts are baked into perception? I think for us, yes, right? Like, yeah. I think that's how we perceive anything. It's like that's the whole point of the predictive processing thing. It's not that it's not that the light hits the pen hits my eyes, and then that causes me to think about the pen. It's that, imagine this situation where I'm holding this thing, I don't even see it yet, and I look at it. That moment where I look at this thing, I've directed my attention before I even get the photons get to my eyes, because I knew, I had in my brain that I was holding a pen and I looked at it. I already expected that, and my brain already acted as if those photons had already hit my eyes. But then once the photons hit my eyes, and there's no error there, then, and there is error, by the way, like, I don't know exactly what this pen looks like, even though I just looked at it. I've already, it's not like I've internalized the exact feel and look of this pen. So my brain is actually, it's just it has some abstraction. But then once I look at it, there's so much detail that's hitting my brain, and that's error in this case. It's affecting my brain in such a way where now what becomes conscious to me are those details. Like, it's the error that actually gives this thing shape. Okay. Phenomenology of emotions is so interesting. Yeah, it is crazy. I mean, it's difficult, but like, we're coming up with emotions though through a physical mechanism of seeing patterns of thought, as well as patterns of self-report. So it's like those two together give us a nice taxonomy. But yeah, like, when I say that our words are only a reduction of our experience, like, we have to keep in mind that I am leveraging concepts about what is possible. Like, I'm leveraging this idea that there could be an experience that's filled with a bunch of things, or a bunch of aspects of feelings. Like, all of that is leveraging concepts that we have internalized, that are culturally contingent, and there's no getting out of that space, regardless of how much it feels like that's just a true fact that's there, that doesn't matter what type of culture we had. Like, our concepts of these concepts are such that they don't matter regardless of who's thinking about them. But yeah, we can't decouple that. I don't know if that makes clear sense, but okay. In meditating on emotions, it seems they appear in an undefinable location and have definable characteristics, except maybe with negative definitions. Have no definable characteristics, expect maybe with negative definitions. Yeah, I'm curious how how this would be intuitively felt by me. Like, the thing that was cool was, like, when Sam Harris was saying, that he discovered that the experience of nervousness and I forget if it was just like exercise was very similar. Like he realized, it's like similar feelings from the body, right? Similar interoceptive feelings of the heart rate rising and whatnot. And so it's really what your brain is trying to first predict that's affecting how you end up experiencing that experience. So yeah, I imagine once you meditate and when we're building this meditation skill, we're inhibiting the default mode network in ways that is telling it like, chill with all the potential ideas of what we are experiencing right now. And by inhibiting that, like you're inhibiting top down signals that are making these predictions, that allows you to you know start with a less committed position about what you're experiencing. So then you can pay attention to what it might be that you are actually experiencing. And so like your prediction could be much more abstract and non-committal, and then you get the error of what you're experiencing, and you're now able to much more clearly notice what the bottom up signals are, because your top down authoritative predictions were significantly less assertive and committal. So like that's the way I'm thinking about this now. It's like, what are we doing by building these skills and by seeing it through these through these leading models of predictive processing? Like it for me, that's profound, and allows me to actually have a really exciting relationship with my practice, where I know that these things will happen. A lot of people, when they hear about mindfulness or meditation and stuff like that, first of all, they might not even know that there's a lot of studies showing that it has positive impacts, but they might just get the spiritual descriptions of this stuff, and at this point, they are operating just on faith, and that might be enough for a lot of people. But for some people, that it might be like, oh, I don't know if this is like actually legit, or it's and they try it out, but like, because I know what's actually happening under the hood, I can go into this whole topic completely confident of that I know that something is going to happen under the hood. And now for me, it's like, how do we navigate this space to make sure that we're getting to where we want to go in terms of what skills we want to build here. And for me, that's super motivating and meaningful and whatnot. And that's like, an example of how you can go about anything with your life. That's the whole point of part one. Like, you might ask, like, why is part one important if we only start getting into really cool practical techniques in part two? It's because part one allows you to understand what is actually happening in your brain when you leverage these part two techniques. And that can create a sense of understanding and meaning that can sustain your practice. Why would you go to the gym if you didn't understand that going to the gym makes you think clearer and makes you experience more positive emotion and makes you experience less negative emotion and all the things that come with it? Makes you learn more, makes you better at learning skills, makes you, these are all cheat codes. And without understanding how much of a cheat code these things are, it's less compelling to do it. I think faith helps, but I think most can feel some benefit, right? Or some huge obvious benefit, right? And also, like, once again, like, the perspective I'm coming from does kind of rely on faith of whatever it is, whether it's the empirical method itself or at least the experts that I've offloaded my trust to. Now, granted, it's not too difficult for me because I've heard so many people talk about these certain topics. But this can also point out why people who are in certain spaces online might think that, certain things do or don't work or do, and it really matters, your social space. Your information diet is everything. All right. I think faith has mixed feelings in the East. Buddha says don't believe things just because someone else told you. He says come and see. right? That's the thing where I would maybe push back on, where it's just like some of these things you just can't see, you know. It's just very like obviously he's pointing out the phenomenological aspects of these things, and there is something phenomenological to feel in these practices, but you don't want to just rely on your phenomenology, because your phenomenology is anecdotal. This is the whole, where do we say anecdote in part one? All personal inquiry begins with the anecdote, a single in the moment observation or experience. The anecdote, in line with our framework, is the explicit manifestation of our implicit understanding. It is the product of all our past learning, our unique personal history, and the vast cultural wisdom we have absorbed through story and social interaction. In this sense, our intuitive insights are reliable as powerful sources for generating personal meaning and new hypotheses. They are the signal that our sophisticated internal model has detected a pattern worthy of attention. However, for establishing general empirical truth, the anecdote is a profoundly unreliable tool. And so this is obviously like, in the discussion of like, empirical truth and whatnot. The point I would make with, that discussion from the Buddha would be that by telling you anything and then saying come and see, he's already primed you, he's already affected how you're going to see. So if you've already read anything that the Buddha said and then you hear him say come and see, then what you end up seeing is not just something that was already there regardless of whether the Buddha said it. The Buddha put something into your mind that is now going to affect what you see. That's the thing I'm trying to argue for. Your culture primes, it predisposes how you experience the world. Even in the case of a mindfulness practice or a meditation practice. Like there's no way I can cut out the constraints of my past experience, even when I go into a mindfulness meditation. What you can do is you can inhibit the default mode network. You could affect other signaling in the brain, but a lot of my memory is baked in to how my signals are wired right now, and that's not something I can just change willfully. But you are meant to take refuge in the Buddha and his teachings with some form of faith, right? I believe. Yeah, I guess that goes to what you're saying. I believe everything says. Let the golden chairman dare lead. Oh my gosh, light the path. We are your soldiers on the revolutionary path, with revolutionary zeal. Oh my gosh, at ease, soldier. It's a bit of both, right? But some of it is on the level of like, if you feel fear, you know it. On what level could that be an illusion? If you feel joy, right? But like, you're discounting the fact that you were taught what fear is, throughout your entire life. Like, the point is, if you didn't have anyone to tell you what emotions were when you were growing up, then first of all, your body would be significantly less able to regulate itself. Like the fact that we understand our emotions as well as we do is really effective for our regulation processes. That's the point. That's why we would end up here in an evolutionary path. But without that type of understanding, we wouldn't be able to recognize emotions as easily, because we weren't taught the different patterns of emotion. And we learn through not just our own understanding and someone telling us what we're experiencing in a moment, but we see it in stories when we see the character is afraid of something that's about to happen. And that gives us a sense of like, okay, when we're in this type of situation, we might be feeling an emotion that is similar to what they're feeling, and we can call it what they're calling it on screen right now, which is fear. And that gives us so much information. That's so helpful for us. So it's like there's never anything that's just innate. in this view, like we can't think of anything as like being truly ontologically prior to our you know, internalized understanding. Like that's why predictive processing is so powerful here. It's everything. Prediction is everything, and then the bottom up signals tell us when our predictions are not right. And yeah, okay. It's been both, but some of it is on the level like if you feel fear, you know it. On what level could that be an illusion? If you feel joy meditating, how can you be convinced meditation isn't capable of leading to joy? Right, right. I mean, like you could say that these types of practices would feel to those bottom up signals, regardless of what you think. Like as a human being, if you were to just, you know, breathe in, breathe out, or to do what Huberman calls the something sigh. I forget what it's called. Like those, regardless of the human, regardless of what they understand, it will affect their body in certain ways. But how they understand what's happening is going to be completely affected by their understanding. So yes, you know, if you feel joy meditating, you're identifying this because that's something you've learned. You can identify that this is that you're feeling more joy than you were before, or that, you know, this feeling of joy is coming out here. But yeah, we can't discount how much the fact that we're primed to interpret it in that way. The party for March 4th says about to be kidnapped. Oh no, please no. If I was never told about fear, I wouldn't feel fear. It depends what you mean by feel fear. Like your body would do similar things, but you wouldn't be able to as effectively understand what is happening with the body. That's the point. So this is why I keep mentioning the predictive processing stuff. The bottom up signals would be similar, but your bottom up signals hit something that's applying prediction almost immediately. And the, you know, as we pointed out, the you know, what's applying prediction often you know, happens before the bottom up signals hit it. Like it's already expecting some signal to happen. And yeah, you know, you might just think this is also a great way to segue or to point back, go full circle back to what we were talking about with consciousness in other species. Like the other species might not be able to understand the complex emotions of where is it? Where is it? Where were we? How far back? Okay, there's one distinction, distinct separation that Barrett makes that is vital for your understanding of the rest of the book. Affect, the foundation, simple feelings of pleasant, unpleasant, and arousal, calm. Barrett argues many species have this because it comes from body budgeting. Emotion, complex categories like sadness, awe, fear. These are constructed by the brain using concepts learned from culture. So yeah, if you didn't have that understanding, or if you didn't have the capacity for that understanding, let's just say, so imagine you know, a chicken as it's being, you know, as it's being carried to the slaughter, like literally, it's experiencing something. You know, the body is doing something happens to all mammals, but it's top down. The parts of the parts of its brain that are applying top down signals are applying signals that are so much lower fidelity than our top-down signals. Like our understanding of fear as this concrete category is not what a chicken can do as effectively. And so like it might just understand, you know, something bad is happening, but you know, it wouldn't be able to differentiate these emotions as easily. Okay. I think we disagree because you don't believe consciousness has universal aspects to understand. Is this accurate? Oh man, this is this is a tricky conversation because like we share a culture. So I could say like within our culture there's probably patterns that given our what our culture provides us, there's patterns that we could both identify and that we could say that's universal. We could say that's transcendent in some aspect. But it's relying on the fact that we have a similar understanding about what fear is and whatnot, that we can actually notice these similar things happening. And you could say these are universal aspects to understand. I'm just trying to say, like, let's not think that these are like absolute ontological truths, but that these are like, I don't know, cultural and circumstantial, but also like they'll always occur with human DNA and these human experiences. So like that's the type of precision I'm trying to get at. But yeah, like this is the same point as the, you know, when we talk about how different moral themes come to be in cultures, you know, cross cultures, that don't ever coordinate with each other. It's like, yeah, it's likely that different cultures are going to arrive at similar takeaways about meditation, because regardless of your language, whatever you designate as joy in your language is going to be the thing that how you make sense of this type of signal that is coming from your body when you do these certain things. And these signals are human in nature. It's in our DNA that this would happen when you meditate in this way. And so you could see these similar patterns, these similar conceptualizations across cultures. Okay. I don't discount that you can meditate in a way that constructs illusory things, but there's an aspect where you can play around and investigate these things to approach a lawyerly level of conviction. You're also not exactly in isolation because you can consult a broad range of practitioners' experiences and their traditions. That's at least how I think about what is really there and what I'm imagining. I've been through both. Does your thinking relate to or interact with the nature-nurture debate? Well, so I mean, the way I think about the nature-nurture debate is exactly how we talk about it in Experience Over Time, a notion of predisposition. So I'm explaining how we're predisposed to experience the world in a certain way at each moment. Genetics, nature, and nurture. The takeaway that we get here is right. Genetics is not destiny. Genetic genome provides a scaffold, one that defines both constraints and affordances. While our genetic code sets limits on developmental possibilities, it also permits remarkable variability in outcome. This variability, driven by gene-environment interaction, explains how individuals with identical genomes, such as identical twins, can nonetheless develop different cognitive, emotional, and behavioral tendencies depending on their unique life histories. Rather than treat nature and nurture as competing explanations, we can understand predisposition as the product of their interaction. The genome provides a range of possible configurations. Experience and environment determines which ones are realized. In every moment, our experience reflects the ongoing expression of this interaction. So yeah, it's like we could have this discussion of what would be, you know, more on the nature side and what would be on the nurture side. And in the same discussion, I would say those bottom-up signals that people tend to interpret across culturally as joy would be nurture. And the nature is the difference of the interpretation. So, yeah, when we arrive at these types of things, the question is, would we say that they're actually, fundamental in the fact that they're transcendent across cultures for humans? And because I'm trying to be as careful in a philosophical sense in this document, I'm not going to leverage the use of the phrasing of like some absolute truth. It's not like there's an absolute truth about these meditative states, because I'm trying not to imply something. Like that's it. Really just comes down to this like linguistic pragmatism at the end of the day, every single time. And I know that shoots me in the foot, but it's also the most careful we can be, and it's allowing me to not imply things that I wouldn't want to imply. But that it also gets me into the situation where you might be thinking I'm not actually agreeing with the aspect of this that you understand. Like so like I think we're in agreement with in terms of like what mindfulness meditation can bring about for any human being that does it. Like what I'm always just concerned about is how we talk about that type of phenomenon. Okay. I was just randomly reading the main Theravada authority, and he said direct experience is the highest level of proof. That's an attitude you see, right? So this is the thing I specifically try to assault in consciousness P2, because people will come up with axioms like this and build build a lot on those axioms, and the question is, does it really matter? And that's a good question. I think it matters for the type of discussion we're having in our document and the type of discussion we have on this channel of being absolutely as philosophically precise as we possibly could be regarding what we know about the brain. What am I going to? I'm going to the ontological takeaways. Yeah, it's the same stuff. We can say that consciousness is the source of each individual's unique ontology, source of all meaning for them. However, we cannot say that anyone's unique experience directly pertains to some external absolute truth. And this is like out of principle. Like, we don't want to purport that there's some authority that's just kind of out there. We may share a similar biology, but each person's nature and nurture differs enough such that these experiences are different meaningfully. They're like, people have different meaningful experiences, and those experiences differ. All right, similarly, our interpretation of consciousness today radically differs from humans from 5,000 years ago. The conceptualization of a hard problem of consciousness, blah, 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 blah. Okay. So any conceptualization we have, even about consciousness itself, is fundamentally speculative and contingent, in the same way that we don't, and I say fundamentally because I'm trying to like really point out that we shouldn't take this as a like an actual invitation for some sort of epistemic nihilism. But I'm saying it's fundamentally speculative and contingent. In the same way that we don't experience the physical world directly, we don't experience consciousness directly. And crucially, this means that we cannot rely solely on intuitive, self-evident features of experience as metaphysical bedrock, even if they feel logical. In other words, we cannot use the intuitive contents of an experience as evidence for that content's truth, regardless of whether that thought feels self-evident, such as the universe feels conscious or my mind feels separate from my body. So, and then, this reveals a primary point of divergence from many non-physicalist views. Frameworks like IIT and analytic idealism, for example, rely on the same epistemological starting point, what you had just mentioned. The Cartesian idea that consciousness is the only thing that we can be 100% certain of. They then elevate this one subjective intuition to the status of a primary, non-negotiable axiom that forms the metaphysical bedrock for their entire theory. All right. Right. Even arguments built on pure logic ultimately depend on the feeling of conviction they produce. Our sense of what is logical or self-evident is not a pure window into truth, but a complex affective and cognitive state produced by our underlying physiology, shaped by our memory, language, and cultural context. All right. It's been coming up in practice, like deconstructing concepts we could use to describe consciousness. Ooh, my meditation practice. Nice. Yeah, like that. That's a great practice. Because Mahayana says it has no characteristics, and Theravada says it has 3 universal characteristics. I think we have to, like, I think it would be most apt to follow it's following a convention, right? It's not like the point is that we don't try to point out some absolute truth. We're trying to point out norms. So a way that we talk about things is normative. For instance, how do you refute the idea that consciousness has the character of always changing? How do you refute the idea that consciousness has the character of always changing? Yeah, so like the thing that I would refute isn't the like the isn't the intuitive conceptualization of that. Like I think that having that understanding is actually quite beneficial. It's like I'm just trying to just point out that that framing isn't without the like our cultural contingency or whatever it is, what we've internalized, understood, like our understanding of change, our understanding of what consciousness could be, the fact, like what does it mean for consciousness to be changing, like all these things rely on presuppositions that I just want to make sure are clear, like that they're in this story. We're not, and so yeah, like I'm not saying that we can't give anything a property in some determinate way. Like that, if we have a concept of consciousness, that would be the property. But it's much more inappropriate to say that like consciousness is true in some authoritative sense, that it's above anything else that we describe as true, and this is the one thing we know to be true. Like that's to me that's more. It has more. What's the word? It has more implication power or weight. You know, it implies more, and especially more than we would want to imply, or at least more than I want to imply. Or experience, rather, whatever word. Right. But yeah, I think it's important to point out the fact that consciousness feels certain. It feels true. Like that's certainly an interesting aspect of consciousness. Not one that we should just shy away from. I think it is beneficial to understand consciousness as always changing. Like it's a really useful axiom to operate with. Just like I think it's really beneficial to think about your consciousness as thoughts arising and going away, and it's not like a space, like we don't know, like it's hard to pinpoint where something is. It's not something we're looking at, because as like Sam always says, like try to find the looker, and that's very difficult. So it's all these are useful conceptualizations. So I'm all about conceptualizations. It's when we start saying what things are, like when things are true in some fundamental sense, that I start getting up in arms. I understand solipsism is seen as a poor insight to build a whole system around, but I don't know how the core idea can be refuted. Not just difficult, not possible. The not finding is the finding. Yeah, that's the thing. It's like, this is where we get to the literal next sentence. This naturally leads to the crucial idea: if all our convictions are contingent brain states, why should we privilege the conviction we feel for the scientific physicalist framework over any other? And in this case, I'm not actually purporting the physicalist framework. I'm purporting the answer must lie in a discernible heuristic, and it's the standards of empirical science that it's faith, right? Like we're relying on this understanding that is completely contingent about what leads to more authoritative conceptualizations about the world. And so only with my understanding of empirical science giving us this sense of what is physically there, can I actually get a refutation of that core idea. It's only once I see that the brain is this dynamic under the hood that allows me to realize that that my experience of solipsism is afforded to me by my affective parts of the brain, or brain processes. The reason I feel like something is true, even about consciousness itself, can be pinpointed to the types of processes that are happening in my brain. And because of that, that's as much refutation as I need. And when I say that, I mean like that's That's all the refutation that I believe that logic and empirical science necessitates. That's the type of argument I make. Oh, in terms of looking for the... Okay. The not finding is the finding. In terms of looking for the witness, sidetrack to what you said. Faith is also a strange concept to me because I think certain is just a spectrum, certainty, and the only certainty is solipsism. Well, yeah, I would say certainty is just a spectrum, but then I would decouple that from this idea that the only certainty is solipsism. Like I would argue that you feel as certain that I am holding a pen right now as you are feeling that you are conscious right now. Like, I think it's a similar amount of affect is happening, or a similar arousal and valence is happening. And, you know, it's not that salient in the sense that it's not causing you to think that that's incorrect in any way. Didn't Descartes say, like, everything physical could be illusory? It could be, right? But like, I imagine that your brain does not think that this is illusory. What you're doing when you're considering that it could possibly be illusory is you're applying this, like, high level, you know, top down thought onto your what would be, you know, very much automatic. Like, the argument I'm trying to make is, like, when you're walking up the steps, the certainty that you feel about the step in front of you is so uninteresting and is so innate that it doesn't even like, I would even argue that if we're talking about the feeling of certainty, that is more certain to you than when you consider your consciousness, because when you're like, when you behave as if you just act as if something's there. You know, if we're going to describe what certainty is, I would say that is significantly more unconscious and automatic than you having to think about consciousness. Like, consciousness is something that requires a little bit more thought than your automatic actions. Right? Like, our brain is wired to literally commit to things in the moment. That's so all of this stuff is like that's the strength of this conceptualizing our understanding section. And we haven't talked through this in a while, but this stuff is so crucial, so huge, because it has us thinking about these types of unconscious interactions with the world as implicit commitments to how the world is in, like, a ontological sense. Like, that's a way that we could think about how our brain works. And through the predictive processing mechanism, that's literally how the brain is described. Like, your brain is, when I say predicting something, it's committing to the world being that way. It's applying priors, and then the world, you could say the world, the external world, whatever you want to say. You could say it's, simply exteroceptive signals and interoceptive signals. Like, this applies your pushback. This is the error that's telling you that the way that you think the world is not right, and a lot of that happens unconsciously. And if your brain determines that it's salient enough to require a bunch of other things to happen in your brain and body, then it will do that. And yeah. Oh, that seems to be the refutation for me. I see. Okay, many Hindus think the physical world is an illusion. That's the idea of Maya. Yeah, I guess another thing to point out is a lot of people argue that, like, consciousness is an illusion as well, and that's like one way to interpret what's happening, and that's why it almost necessitates that we have an understanding of the physical underneath the hood to be able to point out, okay, how could that be the case? Like, what would that even mean for us to have this experience that is completely illusory? All right, right, but it's akin to acting in a dream, right? Common Eastern analogy that the regular world in our waking life is a dream or dreamlike. Funny that the physicalist and the idealist both say the other is an illusion. Right, right. I think I truly think that we can point out that physicalism contradicts itself and idealism contradicts itself. Both of them don't work. They're both too committal on their or too assertive with their language. They're too they're trying to do too much. All right, we went on a consciousness tangent. I think I'm gonna call it here. Um, and then oh, then we'll continue where we left off tomorrow and on this conversation, on this discussion. But good stuff, good convos, because I think I might be getting slightly better at describing these things like every single day we do this, and just like with mindfulness, a mindfulness practice, this is a good practice for me. So we just got to keep at it. We got to keep doing it. This is, as I said, this is our Batman Begins phase. I'm still working with Liam Neeson right now. Like, you know, I'm expecting at some point for this channel to be exposed to more people, and I just need to be ready for it. So that's why one of the reasons why I'm not trying to like rush this growth, because I want to make sure that we're like ready for having to, deal with all the different counter arguments that could be made here, or all the different perspectives that we want to empathize with as well. All right. Whew. All right. Yeah. No. Thanks everyone that was chilling out today, and yeah, enjoy the rest of your day.